Kia ora, Year 12 and 13. Here are two more rational equations for you to practice solving. So this is still off Mr. Vaughan's fantastic equations worksheet. This is exercise A. This time it's questions 7 and 9. Okay, so have a go at them first and see how you get on. Remember, the goal in the first one is going to be to get a common denominator. Okay, so in this first equation, we're told that x cannot equal 0. So even if we weren't told that, we'd be expected to note that down. And the reason for that is that I can't have a denominator in a fraction ever equaling 0, because the fraction will then be undefined. So what I need to do now is to give a common denominator to each side. I'm going to start with the left-hand side, and I ask 7 times what will give me 7x. Well, 7x times what will give me 7x? Well, just times 1. So I don't need to do anything to the 2 in the numerator. For the second part of the fraction, I have to think, well, what has to happen to the numerator and denominator to end up with 7x here? So I'm going to multiply, top and bottom get multiplied by 7x. So it's 2 plus 14x. And I'll just leave my right-hand side alone. Next thing I'm going to do is to cross multiply. So I'm multiplying both sides of the fraction by 7x, and at the same time I'm multiplying both sides of the fraction by 5x. The equation will stay balanced as long as I do the same thing to both sides of the equation. So here's what we end up with. We get 5x times 2 plus 14x equals 21x. Expanding that now, I get 10x plus 70x squared equals 21x, and that's a quadratic. Now to solve a quadratic, I always want to have it equaling 0 so that I can factorise. That's unless I'm using a technique like completing the square. Okay, so I've subtracted 21x from both sides. I can now take out a common factor of x times 70x minus 11. So what will make that equal 0? Well, two things. Either this factor equals 0 or this one equals 0. So I start my usual process and I say x equals 0 or 70x minus 11 equals 0. This one gives me 70x equals 11. X equals 11 over 70. But wait, there's a wee problem. We can't have x equaling 0 because we started out with this equation back here, and we were told at the start x can't be equal to 0. So this is not a valid solution. There's only one solution to this equation, and it's x equals 11 over 70. Okay, now I'm going to go on to the next problem. Right, so this is question 9 from exercise A. It's 4 over x is equal to 3 over 2x plus 1. So just note at the outset what x can't equal. X can't equal 0, and x can't equal negative 1/2. I just need to check when I get to the end that neither of those two things have turned up in my solution set. I'm going to cross multiply here. I get 4 times 2x plus 1 is equal to 3x. So 8x plus 4 equals 3x. 4 equals negative 5x. So x equals, well, let's do it first with what we're actually doing. 4 divided by negative 5. But I never leave a negative sign in the denominator. That's equivalent to negative 4. Oops. Sorry about that. Negative 4 over 5. Okay, so that's my single solution there. Okay, a couple of harder questions coming up shortly.